Hello, in this video I'm going to solve question number 1, problems set 3, lecture 4, lectures in elementary number theory. Let a and b be integers such that a minus b divides a. Show that a minus b divides 2a plus 3b and a minus b squared divides ab. Pause the video at this point and give it a try. Okay, so now let us solve the problem. So as I told you that in these problems, these are designed based on my own lectures on this playlist, Elementary Number Theory, so I will not start from scratch. So by no means I'm claiming that these are the only ways of solving these problems. But I'm trying to use the theorems that I have presented on these lectures, so to practice about them. So here I know that a minus b divides a. Let us concentrate on the first part. We want to prove that a minus b also divides 2a plus 3b. Okay, if you remember in one of the lectures we had this idea that if you give me a divisibility relation, I am allowed to add any integer multiple of the left hand side to the right hand side. Say that m is an integer, I can conclude that a also divides b plus m times a. Okay, so if this is true, this is also guaranteed to be true. This is one of the theorems that we had in the previous lectures. And the other one, which was the lecture exactly previous to this problem set, was that if I know that I have a number a which divides b and simultaneously divides another number c, then if I want to, I can conclude that this a divides any linear combination of these two numbers. So I can conclude that a divides mb plus nc for any integers m and n. Okay? So these are the theorems that are relevant for solving this problem. One way, actually, of doing that. So here I would say that if a minus b divides a, this guarantees that I want to use this theorem. I copy and paste the left-hand side, and I would write the right-hand side, and instead of m, I can put minus 1 plus minus 1 times the left-hand side, which is a minus b. Actually, it is not hard to see why minus 1 works fine, because if I ask you now what is this combination is simply a minus a plus b, so these two are gone, so I get b. So this means that if you grant me that a minus b divides a, I myself can conclude using this theorem that a minus b also divides b. Okay, so now I have the same number a minus b, which divides two different numbers a and b. Now I want to use this theorem. So definitely a minus b divides any linear combination of these two numbers, including this very particular linear combination. So if you tell me that a minus b divides a, and now a minus b divides b, from here I can conclude that a minus b indeed divides any linear combinations or any linear combination of these two numbers, including the one given in the problem. So I can conclude that this is indeed the case, and that will give me the proof of the first one. And the proof of the second one is another theorem. We had this in the previous lectures. If you give me two divisibility relations, if I want to, I can multiply them side by side. So a times c also divides b times d. This is one of the theorems we had in the previous lectures. Okay, so now that is the case, because now a minus b divides a minus b divides b. I multiply the left-hand sides a minus b squared, and then I also multiply the right-hand side. So if these two divisibility relations are true, then using this theorem, I can conclude that this divisibility relation is also true. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.